Hi, this is Team Europe, and our productivity improvement study was done on the under construction Auburn University Central Dining Hall. The team members of Team Europe are seen to the right.
Founded in 1946, Arup is an engineering, architecture, and design firm based in London, England, with offices in 40 countries around the world. In recent years, Arup has worked on projects such as the Jewel Changi Airport in Singapore, the Hong Kong Zhuhai Macau Bridge in Greater China, and the Macquarie University Incubator in Australia. Arup does all of these projects while adhering to its values of trying to shape the world in a positive way. For this project, Team Arup focused on the construction of the Auburn University Central Dining Hall. This project is a $26 million, 48,000 square foot endeavor and is meant to be able to host 800 students at one time. The construction of the new dining hall necessitates the demolition of the Allison Laboratory and is estimated to be completed in April of 2021. The construction of this building began in April of 2020. Arup observed the ongoing construction process of the new dining hall for 1 hour and analyzed our findings. During this 1 hour period, the weather conditions were fair, however, it had rained the day prior, adding weight and density to the ground being excavated and possibly making the job a bit more difficult. The analysis was done through the use of crew balance charts, process charts, and flow diagrams. During this analysis, the main problem with productivity was the idle time of some of the workers and machines. There was also a problem with efficiency, as one operator was operating multiple machines, which wastes time and energy. To improve these problems, Arup would either limit the number of workers and equipment, change the strategy of the use of large equipment like excavators, or use new technology. Through the proposals for improvement of the construction process, Arup can make substantial changes to the productivity and efficiency of this project. By limiting the number of workers and equipment, Arup would reduce the cost per cubic yard by 40% from $2.75 to $1.66. Through changing the strategy of the operation of large equipment, Arup would be able to reduce the cost per cubic yard to $1.68. Lastly, through new technology, Arup could reduce the cost per cubic yard to $1.41 through a 35% reduction in cycle time, but would incur costs due to the new equipment. Through the utilization of any of these proposed changes, Arup would not only be able to save money on the construction of the Auburn University Central Dining Hall, but could complete the project ahead of schedule as well.
Hello everyone. I'll be explaining to you the area under study. The area under study is located at the Auburn University. The campus of Auburn University is in Auburn, Alabama, and has a total of approximately 30,400 students attending the university, including undergraduates, graduates, and professionals. So the project estimated construction time is believed to be approximately 1 year. Student Affairs of the university is the client of the project, and the architect of the project is Perkins and Will. Rabban General Contractors are the general contractor of the project who are in charge of the execution work. This project has a capacity to host 800 people at a time, including special reservable dining zones and retail venue stores. Some of the site challenges can be the presence of university traffic in the neighborhood of the project, and also the site can be considered as a nuisance because of the air and noise pollution. Thank you.
Some of the operation and construction processes involved in this project include grading the site using an excavator, drilling with a drill rig, operating forklifts to move materials around the site, inspecting the drill rig and the auger, laying horizontal reinforcements for the slab on grade and the foundation wall. These operations are performed by multiple operators with specific tasks and assignments to perform based on the schedule. In construction, a crew balance chart breaks down a typical cycle by worker activity. They show what each worker or machine is doing in a given cycle through a chart where the y-axis is time and the x-axis is each individual worker or machine and what they're doing on each time interval. A process chart uses symbols to represent the flow of construction materials in a given operation. A flow diagram and a process chart go together. To make a flow diagram, you first have to map out the area of operation and label where specific workers or machines are on the map. Then, you draw how materials flow throughout the map, labeling each change with the appropriate symbol. A process chart is simply a chronological list of every symbol used in the flow diagram and what happens at each symbol.
The site conditions of Auburn University's Central Dining Hall are currently in fair conditions. The site sits adjacent to the football stadium and parking garage, as seen in the picture. The overall construction site is level and slanted downwards to the left. As you can see in the picture, you can see how the left side of the picture is lower than the right side. There's one gated entry point where machinery and materials was coming in and out. The construction trailer was located in the center of the project. That is where construction managers and staff work at or report to. The machinery being used is 2 Caterpillar excavators, as you can see in the back portion of the picture, 3 Caterpillar small backhoes, 1 Caterpillar skid steer, 1 Bobcat skid steer, 1 Caterpillar end loader, and 1 Caterpillar bulldozer. When this video was recorded, it was on April 29th at 10:30 a.m. and the temperature was 72 degrees, and the site was experienced weather of mostly cloudy skies and wind from the west at 6 miles per hour. The humidity was near 100%. This is due to rain that dropped 0.4 inches in total that occurred last night.
We observed large and small machinery on the site in the form of excavators and a drill rig for the large equipment, and smaller excavators, dozers, and loaders for the smaller equipment. 2 operators operated the large equipment, both operating the excavators while one of them switched between excavation and drilling activities. 2 spotters were also around for a portion of the excavating and drilling activities before moving out of view of the camera, as indicated by the gray areas on the crew balance charts. 2 operators operated the small equipment, with 1 operator assuming responsibility for almost the entirety of the activities associated with the mini loader, and the other being responsible for the operation of the smaller excavators, while doing some miscellaneous shoveling or inspection activities in between excavation activities. As only 2 operators seemed to be present, 50% of the smaller machinery on the site was mostly idle across the duration of the observation. The most significant problems observed on the site have to do with the idle time associated with both workers and machinery, as well as with lacking efficiency of operation among operators and laborers. Some of the main things that we've seen were too many people were associated with the drill rig, more than enough people were responsible for inspecting the machinery, and those who stayed to assist in the operation of the rig left at some point during its operation, indicating that their time could have been better utilized. Overall, there was an excess of smaller machinery since there weren't enough operators handy to perform tasks dependent upon the machinery, and so the machinery simply took up space. And in terms of efficiency, non-optimal occupancy of equipment or allocation of resources led to time losses.
After observing the site for an hour or so and understanding the problems with the site productivity, Arup came up with 3 proposals. I'll be explaining the first proposal to you. As you can see from the report, the original crew has 3 small equipments on the site employed for excavation purpose, with 2 operators and 1 spotter. So we decided to increase the productivity of the overall crew and make the activity under consideration cost effective by limiting the number of workers and equipments on the site. So the mini excavator 2 and 3 along with their operators are suggested to be released as per the new crew balance, and with it the spotter is also suggested to be released, who was present on the site throughout the whole hour but had no actual involvement with the productivity of the crew. Also, proper management of the crew breaks is necessary in order to maintain continuity between the process and to reduce the lag time. This will help to improve the overall productivity of the site and the crew, and the same operation will be managed to be completed under 50 minutes. So this will ultimately help to reduce the cost of the activity by 40% of its original value. Thank you. A second proposal is change in large equipment strategy. So some of the crew and machines were underutilized while using the large equipments. So as per the original crew balance chart for large equipment operation, it had 2 spotters, 2 operators, 2 excavators, and 1 drilling rig. So the spotters only contributed for near about 6 minutes of the whole overall operation time of large equipments. And therefore, we suggest releasing both the spotters, and instead ask the operators to take care of their own machinery. Also, we suggest that one of the large excavators to be released from its job because it's not being used enough, and this will not only help in saving a large amount of equipment hours, but will also specifically help in saving a large amount of equipment budget as well. Thank you.
Hi. So the third proposal we would like to make is to implement new technology. The final proposal chosen would be the adoption of grade control technology for excavation activities. Grade control technology is a machine control system for excavators which helps operators even with the most basic skill sets to control the excavators to do the excavation and grading accurately. Grade control helps speed up excavation process by communicating real-time grade information to the operators directly. This level of automation allows for operators of all experience levels to make use of the system without making any errors. Apart from speeding up the on-field operations, automation through grade control also has allowed for transfer of files from office to field at a much faster rate. Overall, there has been a 35% increase noted towards execution of on-field excavation activities. There's often some amount of hesitation shown towards implementing this technology due to the initial costs involved. The truth is, one can expect a return of investment within 200 hours of usage. So we believe this is definitely the way to go. Thank you.
Hello everyone, this is Dhruv from Europe, and today I am here to talk about implementation and plan costs for urban central dining facility. So the first proposal, which includes decrease in crew size and small equipments. So the present crew involves 2 operators, 3 excavators, 1 labor and 1 front loader, and the unitary cost comes out to be $2.75 per cubic yard. But in our proposed crew, there would be 2 operators, 1 excavator and 1 front-end loader. That will decrease the hourly operational cost to $166.5 per hour and unitary cost to $1.66 per cubic yard. The second proposal involves the changes in large equipments. So the present crew for large equipments involves 2 operators, 2 excavators, 2 labor and 1 drill rig. And currently hourly operational costs are $303 per an hour and unitary cost is $1.89 per cubic yard. So in our proposed crew there would be 2 operators, 1 excavator, 1 drill rig, and the hourly operational cost would come out to be $166.5 per hour, and the unitary cost would be $1.68 per cubic yard. The third proposal involves the introduction and adaptation of grade control technology. As a result of using grade control technology, the efficiency can be increased up to 30%. So in general case scenario, the unitary cost for earthwork from small excavator is $1.91 per cubic yard, but in our proposed technology the unitary cost will come down to $1.41 per cubic yard, but the minimum earthwork required is 71,800 cubic yards to break even on the investment cost for this technology. Thank you.
After extensive observation of the construction site of the Central Dining Hall at the Auburn University, Team Europe has come up with 3 proposals to improve the productivity as well as to reduce the project costs. The first proposal limits the number of equipment and personnel at the site, bringing the cost down by 40% to $1.68 per cubic yard per hour. The second proposal suggests changes in large equipment strategy of the project and it will bring the cost down to $1.68 per cubic yard per hour. The third proposal talks about the implementation of new technology called as grade control technology, which will be beneficial for the project if the total excavation of the project is more than 71,800 cubic yards. If given a choice, Team Europe would choose the first proposal as it requires the minimal amount of efforts, but it provides a lot of financial advantages to the constructor. Thank you.